Hey guys, welcome to my YouTube channel. So this is another video based on computer architecture. So this is the computer performance, actually calculating the CPU time and those other things, right? Now I have an activity here. So we are given the instruction count cycles and all those. Now we are also having a clock rate of 300 megahertz. So these are two machines or two computers. Now we need to calculate the CPI for the machine. So there's a mistake here because I think they just wrote CPI time. No, they meant CPI for machine A and also B. We must calculate the MIPS for machine A and B, calculate execution time for A and B. Now after that we compare. That is the main one of the main aspects of us studying the CPU performance, so that we can compare what the performance of two computers. Now let's start. Basically all you just need to know are two formulas. The first formula, it will be the CPU time, which is equal to instruction times CPI, all this over what? All this over clock rate. Now the other formula that you need to know is the MIPS, which states that your clock rate over what? Over your over your CPI. Now the reason I'm saying that these are the only two that you need to know, especially this one, is because you can just, if you want instruction, which is this one, you can just derive the formula CPI, derive the formula clock rate, derive the formula, and also CPU, you know it. The same thing with, if you are given one of these things, you can just derive whatever you have. Now let's start working on the problem. Actually, now we are trying to compare two programs. Now let's first calculate the program A. We're going to calculate everything of program A. Now on program A, PA, let's start with the CPI, right? Now what is the CPI? How do we calculate it? A CPI, which is called the clock per instruction, are the clocks which ticks when an instruction is executed. Basically, okay, let me just post it. So now let's look at the CPI. Basically, we have to, for us to calculate the CPI, it is the sum of what? Of instruction count times what? The instruction, all this over instruction times 10 to the power 6. Now that you have seen the formula, it means that the sum of CPI times number of cycles, I'm sorry, it's not an instruction here, times let's just do that again, times times cycle, number of cycle, over what? Over your instruction, times what? Times 10 to the power 6. The reason for 10 to the power 6 is because the count is in millions. Now let's calculate the sum of this above thing, right? Now it will be 8 times 1 plus what? 4 times 3 plus 2 times 4 plus 4 times 3. All this over what? Over 8 plus 4 plus 2 plus 4 times 10 to the power 6, which is for this everything the same thing with the above. Since it has its count in millions, we'll be having something like times 10 to the power 6. Now let's since both sides, the denominator and the numerator, we have 10 to the power 6, we just cancel those. Now 8 times 1, it is 8, plus 8 times 3, 12, plus 2 times 4, 8, plus 4 times 3, 12, over how much? Over 8 plus 4 plus 2 plus 4, which means 4 plus 4 is 8, and then this results in what? 8 plus 8, it results in 16 plus 2, that's 18. Now this will be equal to 8 plus 12, that is 20, which means it's 20 over how much? Over 18. I'm sorry, I'm just speaking, I'm just writing what's on my mind instead of writing the accurate thing. I meant 20 here and 20 here, it gives us 40. Now let's just put them on the calculator to see. 40 over 18, it gives us 2.2. Now the CPI is 2.2. Now let's record it down. Let me just erase this everything. We are done with the CPI of program number A, which is 2.2 actually. Just do that. Now since the CPI, it is 2.2, CPI is 2.2. Now let's calculate what? Let's calculate the MIPS for machine A. Now MIPS average is equal to what? It is equal to clock rate over what? Over your CPI, which would be, now this CPI is times 10 to the power 6. Now your clock rate, which is 300 mHz, to convert it into HZ, which is the standard one, it means that it will be 300 times 10 to the power 6. I hope you get that. So I don't want you to be amazed when I write 300 times 10 to the power 6. I'm sorry about that. 300 times 10 to the power 6. All this over our CPI, which is 2.2 times 10 to the power 6. This cancel this. We have 300 over 2.2. 300 over 2.2. It results in 136.36. 136.36. That's our MIPS for machine A. Okay, MIPS 136.36. Therefore, let me just write it down there. MIPS close to 136.36. Now we have to calculate the CPU time, which is the execution time. As I said, CPU time, it is equal to what? It is equal to instruction times what? Times CPI over your clock rate. I hope you understand over there. Now your instruction, it is represented in this let me change the color, that over there. Now, which is 8 plus 4 plus 2 plus what? Plus 4, and then this represent this becomes 18. Therefore, since it's 18, it will be 18. Instruction is in millions, right? which is times 10 to the power 6 times what? Times your CPI. Your CPI is 2,2. All this over your clock rate, which is 300 megahertz, times 10 to the power 6. This cancel this. 18 times 2,2. 18 times 2,2. That is 39,6. 39,6 over 300, which is equal to 39,6 over 300, which is equal to 0,132. That's our time, 0,132. Now let me just, okay, it's fine. Take everything. So 0,132. Let's just oh no, I forgot. I erased everything. I not want to erase everything here. Okay, let's remove that and let's erase what we don't need here. Now basically we have our CPU time, which is equal to 0,132. right? Now what I will just do here, I'm going to just reduce the size of this so that I can have space to work within, right? I'll enlarge it when I need it. Let's just put it somewhere. No, it's still large. Let's just put it somewhere, maybe there. Now let's calculate the performance on what, on machine B. Now for the performance on machine B, now let's start with the CPI. So as I said, CPI, it is the sum of what, of clock per instruction times what, times your cycle over what, over your instruction. Therefore this will result in the following manner: 10 times 1 plus 8 times 2 plus 2 times 4 plus 4 times 3, all this everything times 10 to the power 6. Because of millions. The same thing under we have instructions. What is our instructions? It is 10 plus 8 plus 2 plus 4. 10 plus 8 plus 2 plus 4, it is equals to 24. Now let's calculate what is the above. 10 times 1, it is 10, plus 8 times 2, it is 16. 10 plus 16, 26. Now 26 plus 8 from here, 26 plus 8, that is 34. Now 34 plus 12, that is 46. Now we have 46 here. Since I also forgot something here, it was supposed to be 10 to the power 6 because of millions over there. Therefore 46 over 24 is 0, no, it's not 0, it is equal to 1,92. that is our CPI actually. Now we have calculated CPI. Let's move to what? Let's move to MIPS, right? First put this down in the register. CPI is equal to 0. No, it's not 0. I made a mistake again. Is equal to our time, our 1,92. That is our CPI. Now after CPI, we have to calculate the MIPS. Now the MIPS again of it is a result of what? Of a clock rate over what you call the CPI. Now we have a CPI of 1,92. Now a clock rate of 300 times 10 to the power 6. Now by default on the formula, this should be a CPI times 10 to the power 6. This cancel this, and then we are left with 300 over that answer, which gives us 156,52. Now this is our MIPS, 156,52. Now let's calculate the time. Now the CPU time, it is equal to what? Instruction times CPI over what? Over clock rate. Now your instruction are what? Your instruction are this, which was 24 times 10 to the power 6 millions again, times CPI 1,92 over your clock rate 300 times 10 to the power 6. Cancel this, then you are left with 24 times 1,9 to 1,92, which is equal to 46,08 over 300. Now this answer over 300, it gives us 0,153. Now that is our time, 0,153. Okay, now our CPU time is equal to 0,153 or 4, because that 6 after it to convert it into a 4 actually. Now we have done calculation of machine B. Now let's compare it to what is in machine A, right? We are having A and also B. Now let's start with the time. Now machine B can execute 0,13 seconds, and then A it's 0,15, meaning that B it is faster than A, right? Which means you can just write CPU time of A is greater than CPU time of the CPU time of B is greater than of A, right? Now we gather into MIPS, which are million of instruction per second, which means this instruction per second of A is 156, of B is 136. Now which one is greater? Of course it is the A. It has more instruction than what? Than B. You will deduce that A is greater than B in terms of MIPS. And then CPI, clocks per instruction. We have A, which is less than B. Of course it will be less because B has faster time and A has less time. Then you will deduce that CPI of B is greater than that one of A. So that's how we calculate and compare the CPU performance. Now the main thing of studying CPU performance again, guys, is to compare A and B, or different programs, machine, whatever it is that you want to check their performance. So basically that's the end of this video. Thank you for watching.